The automobile is the dominant form of transportation in the United States, and it will continue to be so. It not only provides us the most flexible form of mobility, it has become an integral part of the American economy. But there is no denying the problems brought by the car, and that's where the Department of Transportation comes in, to help improve the benefits of the car while reducing its social costs. The National Highway Traffic Safety Administration has set out to help make autos safer by establishing standards for all new cars. Now, added to this is the task of improving fuel economy. These goals, safety and energy efficiency, must be balanced with the conflicting goals of environmental protection and economy, all jointly referred to as the S3E concept. The program pursuing these goals is the Research Safety Vehicle, a four-stage program to design, build, and test safety features that could be included in cars by the mid-1980s. By 1985, the large car of the early 70s will seem as outdated as the Model T, as the percentage of small cars continues to grow. But this trend carries with it increased danger for drivers and passengers because of the large vehicles that will still be on the road. The RSV program, therefore, has locked onto the small car as the size for which research can provide the greatest payoff. Two firms have been chosen to design and fabricate economical cars weighing 3,000 pounds or less, capable of attaining at least 30 miles per gallon, while meeting high environmental standards, and finally, able to prevent fatalities in crashes up to 50 miles per hour. The two firms present radically different approaches to the development of an RSV. Calspan is employing a more conservative evolutionary method, basing its RSV on a new production car, a Simca 1308, a front-engine, front-wheel drive car manufactured in Europe. The basic goal is to devise safety features that can be readily adapted to current design and production line assembly. The first step was testing the production model to determine its capabilities and its weaknesses, and to provide a database for analysis. The car was tested for acceleration, handling, braking, fuel economy, and crash protection. It was found to have some very good safety characteristics, but was considered only average for crashworthiness in tests that included a front-to-side crash, a front-to-rear crash, a front-to-front offset crash, and a sideswipe crash. Following these tests, a new front, fitted on a baseline car, was designed to provide zero damage protection in crashes up to 7 miles per hour. Composed of urethane foam, the front is intended to be non-aggressive, minimizing damage to other cars and injury to pedestrians. In a basic move to improve occupant safety in crashes, Calspan installed a passive air belt restraint system for the driver and front seat passenger. In a high-speed crash, a chamber along the automatically affixed belt is inflated to cushion the chest load. Conversion of the Simca 1308 includes virtually every aspect of the vehicle. New features were designed and molded, and the parts pressed from sheet metal ready to be attached to the Simca body. Specific safety features that are being built into this RSV include extending the front section with improved energy-absorbing structures, strengthening of the sill to provide extra protection, strengthening of the pillars inside and out, and strengthening and padding of the door, all helping to provide protection in side impacts up to 40 miles per hour. Safety with style and with features applicable to mass-produced cars in the near future has been the goal for Calspan, permitting a thorough assessment of weight and cost of the S3E features. The approach of minicars has been radically different from that of Calspan. This car is new from the ground up. Its purpose is to provide uniquely innovative features to test their effectiveness and practicality for full production cars. The weight of the car is around 2,000 pounds. The rear wheels are driven by a transverse-mounted Honda stratified charge engine. Its basic structure is pressed, light-gauge sheet metal filled with poured, rigid polyurethane foam, which provides a very strong, very light body with energy absorption features and permits very simple fabrication techniques. The non-aggressive front section provides 3-stage energy absorption. The 9-inch thick front bumper of polyurethane foam absorbs crashes up to 10 miles per hour without damage, and a 15-inch replaceable section behind that absorbs crashes up to 20 miles per hour. Occupants are safely protected in frontal crashes up to 50 miles per hour by the energy-absorbing structure, and front seat occupants are further protected by airbags that feature separate chambers for head and torso. The front end safety features are all concealed by a soft, resilient plastic body glove designed to resist scuffing and minor dents and to minimize danger to pedestrians and other vehicles. Inside, the car offers other novel features. Front seat backs are suspended by a transparent vinyl headrest. Airbags in the dashboard for the front seat passenger and on the steering wheel for the driver make minimal demands for space. And even in cramped spaces, the wide gull-wing doors permit ease of entry and exit for both front and rear seat passengers. The minicar's RSV also includes advanced electronic features like improved skid-sensing anti-lock brakes and computerized radar to warn the driver of impending hazards and provide advanced cruise control. A prototype car has been extensively tested by minicars for handling, braking, and stability. Further testing and evaluation of both the CalSpan and the minicar's RSVs will be conducted independently by the National Highway Traffic Safety Administration. At about the midway point, the RSV program looks more important than ever. The trend to smaller cars will undoubtedly continue. The RSV program will show how these cars can be made safe practicably. The major objective of the program is to provide a sound technical database for future cost-effective safety standards and for voluntary adoption of safety features by the auto industry throughout the world. There is a need to relate the four basic considerations: safety, economy, environment, and energy in vehicle design. The RSV provides design concepts balancing these major considerations, but it is not the final answer. It is the forerunner in the international effort to develop a comprehensive approach for designing automobiles that are efficient, clean, economical, and safe.